All right, hello people watching this. This is the start of whiteboards. We're doing chapter 7 review for Trig. Here's your first question. We're going to do the non-graphing stuff first, okay? So if I ask you this question on the test, just from negative 2 pi to positive 2 pi, where does sine equal 1? You can use your unit circle to figure this out, kind of, right? Or you can think about the graph of him, okay? So see if you can come up with an answer. There should be how many places?
What?
How many answers should you have? Two. There should be 2 places.
A negative and a positive.
Yes, but they might not necessarily be the same, like negative pi and positive pi. Does that make sense? Okay. So think about where the graph of him is located, like what he looks like. Where is the sine value 1? Okay. Where is the sine value 1? Okay. Try and see if you can come up with an answer. There's 2 places where the sine value is 1.
What's a Punnett circle?
What?
What's a Punnett circle?
Nothing.
A
There's
Punnett square?
Why is this more confusing?
Punnett square isn't that where you do like your dominant and recessive genes and stuff?
I always call this a Punnett circle.
So Punnett circle?
It's a unit circle.
Sure.
Same thing.
Okay.
That's different.
Did you come up with an answer?
Feel that.
1 second.
Oh, I'll have to get that.
Alright, I don't care how you do it. I'm going to think about the graph of sine, okay? So sine starts 0, goes to 2 pi, right? And sine starts in the middle, goes up high, down, here, and back up. So this is what sine looks like. That is just going from 0 to 2 pi. We're looking where he touches 1. You see where he touches 1? Right here. What is this place at? That's at pi over 2. Got it? So that's one place where he's touching at 1. Do you see how that works? Okay? Now let's go back the other direction. We want to go from negative 2 pi to positive 2 pi. So he's going to do another one of these, right? Woo. Let me do that again. Okay? Where is he going to touch 1 at? It's not at negative pi over 2.
Negative 3 pi.
Negative 3 pi over 2. Those are my 2 answers. Negative 3 pi over 2, positive pi over 2. Yeah? Okay, does that make sense?
Yeah.
You kidding?
Okay,
You right.
good, good.
I see.
Okay.
All right, let's go. I'm trying to think. Let's do tangents. Let's go from I don't know. Let's go from negative 3 pi over 2 to positive 3 pi over 2. I want to know where tangent equals 0. From negative 3 pi over 2 to positive 3 pi over 2. So you either look at the graph or, I don't know, look at your unit circle. But the problem is your unit circle doesn't go from negative 3 pi over 2 to positive 3 pi over 2 necessarily. So that's kind of a careful trickery thing.
Okay, both of those make sense.
Okay, let's see where tangent,
How do you do this one, smarty pants?
let's see where tangent is 0. I would look at the graph.
I don't know.
Oh, wait.
Where is tangent 0?
I'm just guessing.
Negative.
I'm just gonna guess that one.
Do we know how many there are?
3?
Just one.
Oh, I have 3 answers.
Just one.
There should be 3.
What?
Is it days free?
I think so.
I feel like I got,
Right. Okay.
Yay!
Hey, very nice. So if you graph him, the first period of tangent goes from negative pi over 2 to positive pi over 2, right? And he is touching 0 there at 0, right there. That's 0. Okay. But then his next vertical asymptote will be at 3 pi over 2 and at negative 3 pi over 2, right? And he's going to touch 0 right here and right here. Where are those places at?
I was concerned.
Pi, 0,
Pi and negative pi. Yep. Pi, negative pi, and 0. Those 3 places. Got it?
So I was kind of right.
Yeah.
I had my first 2. Great, so.
Okay.
He just put.
Good.
Because pi negative
All
pi
right, let's do one more. Let's do a cosine.
No,
Other side's
She
zero.
can't count that right
And
now.
zero's not even a number.
She can't count that.
Alright.
No.
Okay, let's do. This one's gonna be a little bit harder. Let's do all places, not just between an interval, but all places where cosine equals 0.
This might happen.
All places where cosine is 0. All places where cosine is 0. All places. When I say all places, what do you need to include?
Plus minus 2.
Plus like 2 pi k or 2 pi n or whatever on the end of it, right? Okay, but you're not completely right.
Oh wait, I did that.
Why?
In the first period, how many places does cosine touch 0?
Where's the smart killer?
Does that look a little bit better?
Nice.
Well, write them as 2 separate pieces.
It's the same thing.
No.
You add 2 pi to that and it's
Well,
I
I
got
know,
it.
but I'd rather have.
Yeah.
Look at you guys go. How does this? Is this? Did I ask you one of these on the review?
No.
No?
not really.
Like you guys have this all figured out. Like how does that?
I
even-
didn't. I don't
I'm
understand.
glad.
I didn't
I
understand
mean,
the first two at first, and then I realized.
All right, cosine. The cosine graph starts here and he goes down and he comes back up. Okay. When it says all places, all I'm looking for is look at the first period, right? Look at one chunk. Where does he touch right here at 0?
Pi over 2.
Pi over 2, okay? And then he touches here at 3 pi over 2, right? Those are the 2 places he touches 0. Now, when is, if he touches here at pi over 2, he's going to touch again, how far later? 2 pi later, right? So pi over 2, I would have to do plus or minus, really, 2 pi n, okay? But then he's also touching at 3 pi over 2, and again, every 2 pi later, right? So 3 pi over 2 plus and minus every 2 pi n, right? Do you see the difference between all places versus just in the interval from there to there, right? Okay. So you should have a finite, just a few numbers here versus down here you should have like plus pi n or 2 pi n afterward. Got it? Happy with that? Okay, let's do some of these. Let's say that I give you, I want you to find y equals, let's say 3 cosine of x, and I want you to do the domain and the range. You could graph it if you want to. It might be helpful. Or you can just think about it in your brain, like where he's going to end up. But find the domain and range of 3 cosine x. What is domain and range of 3 cosine x? Domain and range of 3 cosine
It's
x.
really liquidy marker.
I don't know if we wrote this on at the beginning, but Angel has it on hers. She has a domain and range of just normal cosine on the back of her blue sheet. I don't know if we did that for every single one of them,
No.
but there's that.
Yeah.
She's special. She's special. She got it.
I'm
Switch her -3 and 3 around. So they go in order. And he should be Y.
What?
For range?
Instead of x?
Yeah.
Really?
Yeah. There you go.
That's a real thing.
Okay.
I think I got it.
Does that actually matter?
Yeah.
I don't know what that is.
Yeah. So, for cosine, what's the 3 do to it?
That makes sense. Amps.
It goes up to 3 down to -3. So cosine is going to do one of these, right? And he's going to bounce around in between there. So what's the domain, left and right? All real numbers. Okay, for the range, he's only bouncing around between -3 and 3, right? So there are 2 different ways you can write your range. You can say -3 is less than, should it be equal to?
Sometimes.
Yeah.
Is it actually touching -3? Yes. And your value is y because you're doing range. Less than or equal to +3, right? Okay, or you can go -3, 3, but if you do that, you have to have brackets because it is touching those guys. So put brackets around your -3 to 3. Got it? You guys see that? -3 to 3. Brackets around them or this guy. Okay? Good, good? Okay. Let's do a sign. Y equals, let's say, negative. Okay, let's not do a negative. Let's do
Not right
2 sine of x plus 4, let's say. Find the domain and range. Domain and range of 2 sine of x plus 4. 2 sine of x plus 4.
Oh no.
domain and range.
For me. This is a really juicy marker you got here.
It wouldn't do anything, would it?
It's going to move everything up 4. And then your
Oh,
amplitude's going to be
okay.
2 higher and 2 lower.
How'd I do that?
I wouldn't
Can you see
go that way.
Oh yeah, you taught me.
I think I got it, but oh, I also wrote these back.
Such a juicy marker.
Yeah, put your 2 and your 6.
Question, tell me.
And put brackets around them.
Brackets?
Yes,
Okay.
so that
Oh,
we
we
know
did
that
put
it's
brackets.
including 2 and
Okay.
6. Yeah. Okay. Do we get this figured out?
Put brackets around yours.
Sometimes.
The +4 moves him up 4, right? So we're starting at 4, and then from there we're going up 2 more and down 2 more. So where's he bouncing between? 2 and 6, right? And he's doing like this thing, right? Like all the way through. Domain is still all reals, but range is going to bounce just between 2 and 6. Do you see that? So you can either write 2 less than or equal to y less than or equal to 6, or 2 comma 6 with brackets, right? It has to have brackets. Okay?
Alright, you do that.
Good? Okay, let's do one more of the like the sine and cosine ones. Let's do negative sine of, let's say 2x
That's not good.
minus 3. Ooh, domain and range.
I don't like these.
Domain and range. Negative sine of 2x minus 3. What's his domain and range? Think about what each little number and stuff in there is doing, and if
Wait, no,
if
we took it down.
it may not, there's a couple things in there that may not even affect your domain and range, actually.
Wait a second.
Yeah, look at you. I can't read that.
Well, your marker is too juicy. Why are you laughing?
Sure. Ah, look at you guys. Nothing. You guys are pros. It's gonna be too easy of a test.
I'm lost.
You're lost?
I'm
Okay.
a little lost.
That's
I'm
fine
having
to be a
brain
little lost.
fart.
It's okay.
Yeah.
Okay, are we ready? Just thinking about the graph. The minus 3 is going to move him down 3. 1, 2, 3. He goes like this. That's where his middle's at now. Amplitude is 1. Okay? Now, the fact that he's going down first, that doesn't change my domain and range, right? Like, he's just still bouncing between those. What does this thing change? What does the 2 do?
Nothing.
That changes the period, how wide and how narrow. But he's still going to go forever in both directions, so he's just going to be more narrow like this. He's still going to do one of these. Right? So this doesn't change the domain and range, and neither is this. The only thing that changes domain and range is the minus 3. Okay, so domain is all real still, but range, what's he bouncing between?
-1 and -4.
Nope, negative 2 and negative 4.
Oh, negative.
Yeah, negative 2 and negative 4. So you can either, but negative 4 goes first,
Wait,
because
what
it's
is
the lower number.
Oh, yeah.
The 2 changes the period, but making him wider or smaller is not going to change domain and range, right? It's still going to accordion out forever, right? So either that or like this. Does that make sense? There are things that will change your domain and range, and then there's things that like don't affect it. Don't get like the negative doesn't change it. The 2 doesn't change it. It'll change what he looks like, but not the domain and range. Got it? Let's do some tangent ones, okay? So
Oh, no.
tangent. Ooh, heavens.
Oh, no.
Oh heavens. Let's say that we have tangent of. Okay, let's say tangent of x over 2, and I want domain and range.
Wait, what?
I tried to pick nice numbers.
They don't even do anything.
Tangent of x over 2, okay? Maybe think about what the graph of him looks like. Like, where is his vertical asymptotes located? Right? Tangent of x over 2. Tangent's going to be the doozy, because tangent is a little bit harder. No.
Wait, no, wait.
Could you explain?
Yeah, I'm confused.
But you would say, for domain, you would say x is not equal to that. Does that make sense, right? Because that's where your asymptotes are. Explain. We need some explaining.
Wait, no, I think I got it. Hold on, wait. Oh, maybe?
Oh, you stinker.
No, okay, so this would go,
I think this is it.
that would go there, and then
of
We know what
these?
tangent looks like, right? The little wavy thing. Okay.
Yeah.
The period of tangent. That's what this is being affected. Is
Yeah.
pi over b, right? Okay. What's
that
b?
has to-
1/2.
1/2. Okay. If I take pi and divide by 1/2, I flip it to the top. It's like times 2 over 1, right?
Yeah, so 2
So the period of tangent is 2 pi. His vertical asymptotes split him in the middle. So if he's 2 pi wide, where are his asymptotes at?
no, it'd be pi.
At pi and at
Negative
negative pi. Okay, I think maybe you might be just a touch wrong on yours. Yours too, maybe, right? Okay, so for range, he goes up and down forever, right? That's all reals. But domain, his first asymptote is located at pi. So I'm going to say x is not equal to pi.
Oh, what?
And then how
Plus
often
minus 2
later
pi.
will he have? Plus minus how much?
2 pi.
2 pi x, right? Normally it's pi x because it's tangent, right? But in this case, our period is 2 pi. So every interval of 2 pi, he'll have a vertical asymptote where he's not touching.
So will that first pi always be just pi?
No. It depends on where his asymptotes are at to start with. So let's say, I'm going to change that really quick. Let's do this. Let's say we have tangent of x over 4. Okay, find the domain and range of tangent of x over 4. See how that changes him. Okay, maybe kind of do the same graphing type of thing. Okay, where will his vertical asymptotes be if he's tangent of x over 4? Tangent of x over 4. Your domain is almost right, but your asymptote won't be at pi. Where will your first asymptote be? Yes, now you're right.
His marker is the same. Huh?
Wait, no.
Yes, that is true.
That is confusing.
Mm-hmm. Right? It is a little tricky.
This
It's a
marker.
little
Oh my
tricky.
gosh.
Yeah, look at you go. Hey, there you go. You are close to being right. It's just your plus and minus whatever
Oh,
is not quite right.
right.
Okay. All right. Okay. So here we go. Yeah, we're doing okay. Like this is not too bad. Your b value is 1/4, right? So you have pi divided by 1/4, or the period now is, if you flip them to the top, is 4 pi. So tangent is now 4 pi wide. And my vertical asymptotes are on either side. So where will each one be at? 2 pi and negative 2 pi. Okay? So x will not be located at 2 pi. And then when will the next asymptote later be?
Plus minus 4 pi.
Plus minus
X.
4 pi x, right? Because that's what my period is. Does that make sense? Every 4 pi later, he will have a vertical asymptote. And range is all reals. Got it?
Can we do transformation?
Transformations, do you want to graph some?
No, I just want to be able to list them out. Because
Oh,
that's
okay.
the one-
Sure,
that's
sure,
the one
sure.
part I kinda
Like the
struggle
amplitude, period, phase, reverse,
Yes.
shift. Okay, we'll do those next, and then I'll give you some where I list them, and then you put them back into the equation. So we'll go vice versa. Okay, here we go. So y equals. Let's do a bunch. We'll do everything, right?
with. Okay.
Should we do everything? Negative 1/2
Forget that.
sine
So bad.
of, let's say 4x minus pi plus 7. That has like all 5 things in it. And I want you to describe the graph. Do you know what I mean when I say describe the graph or list the
Amp,
transformations?
period.
If you want to just do amp, period, phase shift, vertical shift, there you go. I will not on the test make you graph something that has all 5. I don't think. I'm pretty sure I don't. I know that I don't. Okay, I do make you graph, but they only have like 1 or 2 of those things happening. Okay, all right. So there you go. List those out. List those guys.
Oh.
Okay, find each one of those. There's 5 of them. Don't forget the 5th thing. Right? There's technically 5 of them.
Oh no.
7 and 4. Yeah, that should be right. Your phase shift should be positive. Because it's negative C over B, right? It should be
Oh,
positive.
it is positive? Okay.
Your phase shift
But
should
that's
be
right,
positive.
you leave the pi on.
Yeah, pi over 4. Phase shift. Okay. You want me to write down my answers so you can check? 1/2 period 2 pi over 4, which equals pi over 2. Phase shift negative pi over 4, which is positive pi over 4. Okay, which means to the right. If you want to put that in there, you can put right pi over 4 because it's positive now. And then up 7 and flip.
I always struggle with my phase shift.
Okay, yeah. The thing that people struggle with phase shift, you know what? The thing that people struggle with phase shift is, this is what I see a lot of times happen. Don't do this, right? When you go to do your phase shift, you know it's negative C over B, right?
But we don't.
Here's what I see people do a lot. Don't do this. Ready? People I see do this a lot. They say C is negative pi. Got it. Negative pi. But you know what they use for B? Pi over 2, because that's what the period was.
That's what I was doing.
The B is from the equation. It's the 4, right?
Okay.
But a lot of people use the period as the B because you use B to find period, and then they're stuck on the pi over 2, and then they put that in the thing, and then it's just a whole dang mess, right?
That's what I do.
4 is the B, so use that from the formula. So don't do that, right? That's what that's what the mistake you're gonna make if you do, right? Okay, so there's that. All right, let's do a tangent one. Y equals, let's do 4 tangent of, let's do x over 6, sure, plus, we'll do this, pi over 2, and then minus 3. I don't know. This one has everything except 1, I mean, and you know which one it doesn't have.
This is just.
Chase?
What?
Go, get to rolling. I don't think your phase shift is right.
When you multiply it to the common denominator,
I don't think your phase shift is right.
I know this is right.
I don't think your phase shift is right. I think your phase shift is right.
Yeah.
Yeah.
Oh wait.
Okay, amplitude I got 4, period. Do you use pi or 2 pi?
Pi. No, just normal.
it just depends.
Pi, because it's tangent. Over, B is 1/6, right? If I flip him to the top, the new period is 6 pi, right? Okay, phase shift is negative C over B. I'm going to do it over here because that's why I wrote. C is negative pi over 2. Over B, what's B? 1/6. Okay, so if I flip him to the top, that would be times 6 over 1, right? Okay? Alright, if I multiply these, this would be negative 6 pi over 2, which is negative 3 pi. So he has 3 pi to the left. Do you see that? 3 pi left, or you can say negative 3 pi. Either one. Okay, and then down 3. You see how that works? Okay? Good? Good? Alright, let's do some where you put them back in. So I want a cosine function. I want a cosine function where the amplitude is, let's say, 7. I want the period to be, we'll do a hard one. Let's do period as pi over 2. Okay? Let's say the phase shift is left pi. And let's say vertical shift is up 9. I don't know. We'll do something crazy. And he's flipped. Ha. We'll do all of them, right? Put them back in. Erica's starting off with putting all her blanks in. I like that. Like, that helps me significantly. That way I know what I'm missing yet. Okay? So put your blanky blank things in there. I want a cosine function that has all of that going on.
Oh my goodness.
Okay? I mean, even if you struggle with these problems, you should be able to at least get half credit by doing the amplitude and the vertical shift. I mean, like those you should not screw up. Don't screw those up.
Wait, would that? Okay, we'll come back to that.
I don't think your C part is right. I don't think your C part is quite right.
I know I mixed them around.
Yes, I think that is right.
I think I got it.
I think that is right.
I didn't give myself enough space.
Is that minus?
I know where you like. Yeah, minus 4 pi.
It should be plus, because if you're going left, pi. It should be plus. Right? Right? True? Because this left actually technically means that that's a negative, right?
Wait,
Yeah.
can I cross out my? I'm so confused on how
Your
to
B and your
do-
C are not right, Jake.
I don't know how to do my period.
Yes. All right, here we go. Let's go through it. If you're struggling, here you go. Blank. Oh, whoa. I don't know why that's big. Blank. Blank X, blank, and then blank. So I know that this is -7, and I know that this is +9. Right? Okay, to find period, I do 2 pi over b for cosine, right? But that has to be equal to pi over 2. Do you cross multiply?
Yeah.
Okay, so pi b equals 4 pi, and if you divide by pi, b is 4, right? The b value is 4. Okay, so 4 is there. To find the phase shift is -c over b, but we already know b is 4. I want that to be equal to how much? Negative pi. Be careful because here I said pi, but I said left pi. So make sure that you set it equal to a negative. All right, the negatives are going to cancel each other out, right? So I just really have c over 4 equals pi. How do you want to solve for that?
Pi over 1.
You want pi over 1 and then cross multiply? Sure. Okay, so 4 pi is 4 pi equals c, and that's it. 4 pi is c. Is it a positive 4 pi or a negative 4 pi? It's positive because here it was negative, right? So it goes in there positive. Makes sense? So that's your deal, right? Should we do another one of those? We'll do tangents this time. Okay? How about let's do cotangent? Y equals. I want cotangent.
Okay, fine.
Okay? Amplitude, period, phase shift, vertical shift. I want amplitude to be 1/2. Period to be, let's say 4 pi. Phase shift to be right pi, and vertical shift to be up 1. I don't know. So, when you're doing this one, really, if I give you cotangent, is that any different than writing tangent? No. It's just that graphing would be different, right? But like as far as writing the equation, it shouldn't be any different. Okay, put him back in.
Did I do this one right? Where'd you get that? You get that?
Your B is not right.
But my face shirt.
I think mine's right.
So if your B is not right, your C is not right either. Your B is not right, I don't think.
Is my B at least right?
I think I got mine right.
Your B is close to being right, but not. Your B is right.
But my C isn't? What's your B?
And your C is right also.
Wait, what is your B?
Is mine right?
Is that better for my B?
No, but you're getting closer.
Is that better?
No.
I got really
You're right, I think.
Yeah.
What do you have, Jake?
Your B is right now, but your C is not.
What did you put? Let me see this.
How is it the same?
It's not the same.
Oh, I know what I did.
Is that a plus or a minus pi over 4?
Minus C.
Yes, I think that's right. You should be right.
Okay, now I'm stupid. I was using the other. I was using 2 pi.
Okay, so here you go. Blank, blank x, blank, and blank.
Do it on whiteboard.
This should be 1/2. This should be +1. Even if you're struggling, like you should at least get those two, maybe. 4 pi. Okay, how do you find period of cotangent?
Pi over b.
Pi over b, and I want that to be equal to 4 pi. Okay, so then what? You want them over 1 and you cross multiply? Sure. Okay, so 4 pi b equals pi, right? And then divide by 4 pi. Okay, so the pi's cancel, so b is 1/4. Yep, so that goes here. 1/4 x, or you could put x over 4. That's fine. All right, I want negative c over b to be equal to right pi. Does that mean plus pi or minus pi?
Plus.
Positive pi, right? Okay. All right, I want this to be 1/4. Ooh.
Over 1.
You put pi over 1 and cross multiply? Okay, so there's that. 1/4 pi, which is the same thing as pi over 4, equals
Episode 9.
negative c. So then divide by a negative, so negative pi over 4. Negative pi over 4. There you go. Okay, if you're going to do this, I would strongly suggest, at least for your period and phase shift, after you get them plugged in, pull them back out and see if it comes out right. Does that make sense? Like, do the thing to see, do you come out with 4 pi and do you come out with right pi? And then you can check your answer, right? Like, you might as well do that to check your answer. Got it? Okay, do that. I'm trying to think.
Just sketch at least one cycle.
You want to do some sketching now?
Yeah.
Should we do some sketching?
Yes.
Okay.
We need to put everything else.
Any in particular that you want, like,
How many
Cotangent,
Can we do
please.
some or tangent?
some tangent ones? What?
How many on the test do we have to graph?
Like
One of each.
2, maybe 3.
One of each.
Can we do cotangent?
I'm assuming you have to
review, like you said. Can we do one of each?
One of each? Okay.
Yeah.
Do you want in particular, like, more phase shifts, more amplitudes, more?
All of it.
Amplitude.
My amplitudes are easy though.
Yes, all of it. We can
Just
get
give us
better
ones
at
that are
all
gonna
of
be
it.
on the test.
Just give us the ones that are. All right, let's start with sine. Let's do negative sine of.
What is that?
Let's do 2x
Look at
plus 4. Holy cow, that's a lot of stuff.
Oh my.
Negative sine 2x plus 4.
Juicy.
And the plus 4 is on the outside of the parentheses, which means that's your D value. We are missing a C value, which is the icky one.
Good.
I would still write out like amplitude, period. You don't have to, but it helps me. Amplitude, period, phase shift, vertical shift. And don't forget the flip. Okay, don't draw him until you have your ruler labeled.
If it's over.
He's not shifted left or right at all.
Does he go up? Like, does he go down?
He's
Since
up
he's-
4.
Oh, okay.
Oh, it's so annoying. Wait.
Someone starts at the bottom.
And we're flipping it, right?
Did I do this right?
Middle?
I don't think I did.
You should start at 4. Yeah.
Oh
should be
no!
right.
Wait, he starts at 4.
Because it's plus 4.
So his middle line, he
Oh, wait, no,
starts
it
in the
goes
middle.
down first.
Ugh, my drawing looks terrible, but anyway, that's something that's what should kind of look like.
Mine doesn't have any lines.
But
Mine doesn't have any lines.
that's fine. Okay.
You're only
Okay, make sure that you're labeling like these guys here specifically and like this guy here specifically.
Doesn't your dad have
Okay.
a CDL?
Make sure you have those at least labeled so I can tell what is what.
Do anything when you graph? Like the B value?
That just changes because so your period is instead of being 2 pi, it's pi.
Oh wait, I should probably label this.
Looks like in
Right?
different classes.
Kind of.
Yeah.
My drawing's good.
Yeah, there you go. There you go, that's fine. Oh, except he should go down first because he slipped.
Oh, okay.
Right. That's the only other thing. Okay, got it?
Okay.
All right, that was sine. Okay, good?
Yep.
Let's do a cosine. Y equals, let's do cosine of, well, we'll do, let's do 2.
Spin it.
Let's do 2 cosine
Okay.
of x plus pi.
Uh-huh.
Sure.
That's it?
That's it.
That's it?
2 cosine of x plus pi. That's all. 2 cosine x plus pi. Ooh. I'm thinking.
Oh, really?
Mhm.
What are you thinking about?
What problem I'm gonna do next?
Wait, right? Yes.
We're done. Cool, you done.
We'll do a tangent one here in a second. And then we'll be done.
Yeah.
Just like that.
How's this look, James?
Oh, it's
What? The what?
Mine's weird.
Oh, you right.
I'm gonna do it right.
You are
I'm
so
messed
right.
up on the face.
Except you didn't go to the left
Did I do it right?
pi.
Oh.
Dude, James
Yeah.
is good at these. He's a mathematician.
Yes, he.
Graphs are so rough.
Yes, that's good.
So there should be.
You did negative.
Wait.
Because you started down first. He starts up first.
Yeah, negative.
Just at the top, you start. I just cut off my 2 pi that way, because then it's like this is my.
How's that look, James?
This is just pi.
James?
Yeah. But he should go, so like if he's left pi, he should start at negative pi and go to positive pi, right? But and he should go up to 2 and down to negative 2, right? So he should start here and go like this.
Why?
That's what he should do.
You should be upward.
We're doing cosine.
Yeah.
That one was confusing.
Does that come
Can you
puzzling?
not put a phase shift on there?
But I got it.
I'll make sure it's
I become
somewhat of a nice
lazy
phase shift.
competent.
Okay, that's not bad.
I'll make sure I phase shift in pi over 5 or something like that for you.
What does that even mean?
I hate phase shift.
Like that. Oh, let's do a tangent. One more.
Oh, God.
Hey,
Get a grade.
yeah. Let's do 4. You want a phase shift?
No.
Yes.
Please no, please no, please no.
No.
4
No phase
tangents of. We'll make him kind of nice. We'll make him kind of nice.
Yeah.
Don't do a face.
X over 2 plus
Oh.
5.
Ooh, that hurted.
Oh wait, we just.
Whoa, this one's gonna be tricky.
I bet so.
Tricky. Tricky.
That is spell you right.
Find all your stuff. Last one.
Wait, no.
Something like that.
Wait, right?
That's gotta be something. Ball.
Wait a second.
This is wrong, right?
I like it.
It's wrong.
No, that's right.
Oh, that's your
Kind of.
Kind of right.
Kind of. Your 4 is kind of a weird thing going on there, but anyway. Yeah.
How do you
I don't know, ask Comacher. How's my
I
interview?
just randomly.
What?
How's my interview?
Good. Yeah, you're really good.
Wait, but if my
How's
amplitude.
Tate?
Good. I thought he was gonna be more nervous than he was, but he wasn't. He was
A
did a really
little
good job.
better than your. It's
don't know.
Well, yes, you do.
I don't know.
You literally.
She can't tell you.
She literally can't.
Secret.
Literally.
Yeah, I don't know how.
Secret.
You moved him up 4 instead of making the amplitude 4.
Oh.
How was that
Oh wait,
working?
B is that.
No.
That's what I did. 1/2. 2 pi.
Oh, you're right. Why exactly?
Okay, if he's starting negative 2 pi for a phase shift, start him over here at negative 2 pi.
Why?
Negative 2 pi, that's where we're gonna start him, right?
Oh yeah, then I was right.
Oh, wait a second. Wait a
Type No, it needs to be
Because then you
it needs to
wouldn't
be over more because if it was
Yeah. Negative 2 pi. Ooh, this is tricky. Negative 2 pi, and he's 2 pi wide. Okay, so that means this is where 0 is, right? So like normally he goes like this, right? So at negative 2 pi he would be at 0 right there. Okay? And then so he's touching this spot right here. And he is 2 pi wide. So I'm gonna have a vertical asymptote on this side and a vertical asymptote on this side, and that whole thing has to be 2 pi. So where's my vertical asymptote gonna be? Right here.
It'd be.
wait, what?
It'd be 1 side.
So 2 pi is your 0.
2 pi is your 0,
And you have to go
and he's 2 pi wide, so that means he's pi on this side and pi on
So
this
pi
side.
over 2 and 3 pi.
So what's wrong with
No? What?
No, but if you
It's
add 2 pi,
0.
wouldn't that be 0?
No.
Oh, it has to be 2 pi. No,
2 pi is where he's split between.
So negative pi.
I thought it was-
Negative pi and negative 3 pi.
Oh, it
Right?
is 2 pi.
Can you
Yeah.
inform me?
I have to put
Okay, well, just wait a second. You might be right. You just did the different cycle than I did. So he'll go like this. Oh, wait a second. No, but he's up 4.
No.
So 1, 2, 3, 4. So this middle part right here will be all the way up here. So he'll go like this. And then negative 4. So he'll be like really straight up and down.